Hey, what's up, folks? This is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. Welcome to our very second installment of a mini Fragment episode. Now, in the past, we have mentioned the book Effective Java by Joshua Bloch on numerous occasions. This book is just pure gold for Java developers. Essentially, what Joshua has done is taken the efforts to compile rules and practices generally held to be the best by most experienced programmers. Now, this is essentially a seminal book for anyone working with Java. If you want to get serious about your Java development, then this is almost like a requirement for reading. Now, a note about this book is that it's not meant for absolute beginners, so you should already have some knowledge of most Java constructs. For example, if we mention constructors, interfaces, abstract classes, and the likes, you should probably have a good idea about what we're talking about. Now, Joshua Bloch, who I shall now endearingly start calling Joshua, basically split these learnings that he compiled into what are called items. Now, there's a grand total of 57 of these items, and that can probably be a lot to take in over just a weekend or a single sitting of a book read. Because each of these items, as he calls it, is dense with both content and information. It really takes time to absorb each of these items and truly understand and learn and incorporate these into your development. So to sort of make it easy for our listeners, we decided we'll take each of these items and explain it in detail over the course of a Fragment episode. So technically, if things go as per plan, eventually there should be 57 of these fragments released for your learning pleasure. Some housekeeping before we actually begin. I'm going to be using the second edition of his book, Effective Java. We'll add a link to the show notes if you want to follow along with our reading. The way we're going to structure each episode is first we're going to state the item as Joshua intended it. Then we'll explore some of the advantages and disadvantages of this pattern, and then how to look at this in terms of an Android developer. So in the context of an Android developer, what are some examples where this pattern is being used or could potentially be used? Does it really make sense in the Android world? Because a lot of these items were compiled with the enterprise Java developer in mind. So we're going to look at it from the eyes of an Android developer. Now, another side note, he's sort of structured each of these items into chapters or sort of like larger categories. So the very first chapter talks about creating and destroying objects. So the first set of items that we're going to cover will be with regards to creating and destroying objects. So without any further ado, let's start our very first item. Item 1. Consider static factory methods instead of constructors. What does that even mean? So whenever you want to grab an instance of a class, how would you technically do it? You would new up an instance using the constructor of the class. Now, there's an alternative pattern to using constructors, which is basically the static factory method. Static factory methods are simple static wrapper methods. Now, because they're static, you don't necessarily need an instance of the class itself to access this method. So you can call this method directly from outside when you want to create an instance of the class. And because it's a factory method, what factories do are create objects. So basically, the factory method creates an object. A common example in the world of Android where we use static factory methods are the toast class, your friendly toast class, which will probably soon be forgotten courtesy the nicer snack bar class, but I digress. Take the example of a toast invocation. So you have toast.makeText, and you usually pass in 3 parameters. The context, the second parameter is the string, the actual message that you want to be shown in the toast, and the third is basically the duration for how long you want the toast message to be shown. So this is a very common example of a static factory method used instead of a constructor. In the same way, you also have, especially in terms of animations, you have the object animator class. And the object animator class is a much nicer demonstration of this static factory method pattern because you can sort of see the benefits. For example, if you wanted to create an object animator, there are three nice static factory methods. There's object animator of float, object animator of int, object animator of argb, and the likes. So all of these produce object animator objects. So they create instances of object animator, but because you can sort of provide specific names to these methods, it makes it much more nicer to sort of understand how these object animators are to be created. Now, static factory methods can exist instead of constructors or also in addition to constructors. Now, in the case of a toast, take a guess. What do you think? Do you think it exists instead of constructors or in addition to constructors? Well, if you guessed in addition to constructors, you guessed right. I'm not personally a big fan of having both of these because it sort of like confuses the consumer of the API. Which one should I use? Should I use the constructor or should I use the static factory method? So it's preferable to usually just keep one, but there could be cases where you necessarily need the constructor to be public and exposed. In the case of the object animator, it's done in a more controlled fashion where each of these static factory methods of float, of int, of argb are the only way you can create these objects of type object animator. There's also a public constructor, but it's basically useless. You can't really create an object animator. So if you have a look at the source code of object animator, it'll make more sense. You'll understand what I mean exactly. Okay, so we talked about the item. What are the advantages of this item? What are the advantages of this pattern? The first and probably the biggest advantage with this pattern is that you can control the name for the method, which basically means if you can control the name, you can give it more meaningful names. Constructors, by definition, have certain restrictions. The very first restriction and the obvious one is a constructor can only take the name of the class, right? So hopefully you give your classes a good name and then the consumers of your API would have to use only that constructor. Now, if you want to qualify the object that you're creating, the way you typically do that with constructors is you pass in parameters and hope that the consumers will figure it out using a combination of your constructor and the parameters that are being passed. Another big restriction on constructors is that any class can ever have only a single constructor with a given method signature. Now, there are workarounds that developers do. They try to change the signature by shifting around the position of the parameter inside the constructor call. That is a terrible, terrible idea. Don't do this. It's heavily frowned upon, and we can go into detail as to why that's frowned upon, but that's for another time. If you feel the need of creating more than one constructor with sort of similar signatures, but because they produce different objects for some reason, then a static factory method is definitely the route that you want to go. So that's the first biggest advantage. Another huge advantage that exists with static factory methods is that unlike constructors, you're not required to create a new object each time they're invoked. So what this means is that you could possibly cache instances as they're constructed. So assuming the object that you're trying to create is expensive, you could cache this object and return the same object. And this can be a huge saving, especially for us Android developers, where sometimes you're dealing with very limited memory or resource, or you care about how costly an object is to be created. So in those cases, a static factory method works very well. Also, another restriction that static factory methods don't have as compared to constructors are that they allow immutable classes. Now, there's another item that talks in detail about these immutable classes. So that's on the docket. So don't worry too much about what immutable classes are, but basically think of them as classes whose values don't change, and they help greatly with reducing design complexity. So constructors don't necessarily allow that because of the restriction that they impose of requiring a new object, but static factory methods are able to avoid that problem. There's this concept also called of instance controlled classes, and what these are basically classes that maintain strict control over what instances exist at any point of time. So by way of using a static factory method, you could, as I mentioned, return the same object for repeated invocation. So you could keep calling your static factory method multiple times and return the exact same object each time. So if your logic sort of requires that, then you have that option with static factory methods. They also allow a class to guarantee a couple of things. So unlike constructors with static factory methods, you could guarantee that an object created is a singleton. So if that's a requirement for you, then you can always ensure that there's one instance ever created for that particular object. There's an item coming up very shortly. It's actually the third item which talks about singletons. So we'll go into detail there again. Another guarantee that static factory methods can make is that you can ensure that certain objects are non-instantiable. So what that means is if you want to restrict the number of instances created for an object, you could sort of privatize the constructor. So by doing that, you can't new up the object, which means you can limit people from newing up and creating instances left and right. The third huge advantage with static factory methods is that you can return any object that's even a subtype of the return type. So again, a restriction with the constructors is that the object being returned has to be precisely the exact same type. But in the case of static factory methods, because it's just like any normal method, you don't have the restriction of returning the exact same type. What you could do is possibly return even like a subtype of that specific class. So this is a huge advantage, and this can be seen in the collections framework for Java, where sometimes you can return either a list or a collection. So it adds conceptual simplicity to your code. We talked about the advantages. Let's even talk about some of the disadvantages for this pattern. The biggest disadvantage is that classes without a public or protected constructors, as we talked about, can't be subclassed. So if that's a requirement for you, if you need to sort of subclass a specific class, then unfortunately you can't really make the constructor private. You have to have at least be protected or public. That's a consideration that you have to make. Now, if you're being gung-ho about your design, arguably that's actually an advantage because it encourages composition over inheritance, which is again one of the biggest and most glorified items made in this book, but we'll get to that item in some time. Another disadvantage with this pattern is sometimes it's not readily distinguishable from other static methods. So in the case of a constructor, it's pretty simple. Anytime I want to new up an instance, as a consumer of the API, I know what my options are. I know my option is simply just new off the class name and boom, I'm done. With static factory methods, because you're given the freedom to sort of create any method name or sort of control that method name, sometimes it can be hard for the consumer of your API to know which static factory method should I use. So the way you combat these is by using proper conventions. So make sure you use good conventions. That way it's easier for people who are using your API to use these static factory methods in a constructive and easy manner. So what are some of the takeaways as an Android developer? Now, Joshua is a very smart person, so the way he's worded these items are with great care. Remember, the item says consider using static factory methods. He doesn't say always use static factory methods. He says consider using them, which means you have to understand the merits of both using them and not using them, and understand when it's appropriate to use them. So I want to leave you with a couple of examples where this pattern is extremely useful as Android developers. The first one is when you create fragments. So assuming you don't have anything against fragments.
Round 1. Fight!
You could use a static factory method, new instance, to create your fragments. So this is a common pattern these days. And within this new instance method, you new up your fragment using the basic constructor. On this instance of the fragment, you essentially add bundle arguments. And the reason you want to do this is because it's actually a common Android developer interview question. So why can't I simply just use the constructor and pass in parameters? You don't want to do that because sometimes if the fragment is recreated by the OS, you want the same parameters that were passed in at the time of instantiation to exist with the fragment. I don't want to go into great detail, but this is just a side note. That's why it's a good way to create instances of your fragments. Use the new instance static factory method. Now, Alex Lockwood has a great post where he talks about this new instance pattern in great detail. I'll add a link to that in the show notes. So if what I said doesn't make too much sense, read that blog post. Another example is usually when you start a new activity, you need an intent, which is sort of the basic way Android works. Usually to build this intent, what I've noticed in certain places is people just create the intent at the point where they want the activity. The problem with this is if you want to launch the same activity from multiple places, there could be a lot of like repeating code in multiple places. So a nice way to sort of combine and dry up this logic is to actually have a new intent static factory method on your activity. So anytime you want to start an activity, you just call this new intent method, and you can make sure that in a single place you have a method that gives you an intent with all the necessary parameters and arguments bundled into this new intent. It's good development practice to make sure that there's a single method or a single location that's responsible for performing this action. That way, if you change it just here, then in all other places where you're making the call to start this activity, the change that you want is reflected. So these are two great places to start using static factory methods right away. There are many other places where you could use static factory methods, so keep an eye out on these anytime you encounter them. I hope you understood and enjoyed this item, and hope you power on with this new tip in your arsenal. If you want to get in touch with Don or me or both of us, then our Twitter handles are Don Felker, Kaushik Gopal, and FragmentedCast, respectively. Hope you enjoyed this item, and we will catch you in the next episode.